Hello everyone and welcome to another STL Partners webinar, this time in partnership with two partners who I'll introduce shortly. The topic for today is private 5G. What is the business case for the manufacturing sector? So really looking at the intersection between telecoms and the industrial space. To let you know and introduce those who will be on the webinar today, we've got 4 speakers. I'll be the moderator, so you'll see me now and then at the end when we do the panel Q&A. Other than that, we have Niels Koenig from Fraunhofer IPT, and he's the head of department coordinator for 5G ICE. For those who aren't aware, Fraunhofer is a leading research organization based in Germany with many units. Niels' department is based in Aachen in Germany, and they specialize in applied research. We also have Raphael Kiesel from WZL, which is part of RWTH in Aachen. He's the head of department there. So just so you know, WZL is the Laboratory for Machine Tools and Production Engineering within the university. And then finally, you have my colleague Yasmin Luk, who is Principal Consultant at STL Partners and also leads a lot of our work in private networks and heads up the telco cloud practice. And then there's myself, Dalia, director in the consulting team, and as some of you know, I've been involved in a lot of the work around edge computing to date as well. So just in terms of the agenda, we have 3 presentations today from our 3 delightful speakers. Yasmin will kick us off with an overview on the understanding, or just to help understand the private 5G opportunity in manufacturing. Then it'll be Niels with his presentation, Sparking the Future of Manufacturing with 5G. And then finally, Raphael, who will go through making 5G pay, how to measure the real impact, and take you through a demo of the tool that we've been developing, which does just exactly that, so measuring the impact of 5G. And then finally, we'll have the Q&A. So as I said, I will be moderating the Q&A. Please do send over your questions from now if you have any questions on the topic. And we'll try and get through as many as possible in the time. Before we kind of kick off with the presentations, I just want to run through a bit of housekeeping. So the first thing is to say that you are in listen-only mode, as you should know, in an STL Partners webinar. If you do have any challenges or any problems, please type in a comment through the chat box. So you should be able to see in the panel on the right-hand side. If you have any questions for the Q&A, please use the questions box so we can make sure, or I personally can make sure to include that when we run the panel. And just so you know, we will share the slides, we'll share the recording of the webinar after the session within the next few days. And do feel free to share that with any colleagues who couldn't make it today and will be interested. As always, if you're on Twitter, feel free to tweet us on any of these 3 Twitter handles representing the 3 organizations. So just before Yasmin kicks off, we've got a little poll to gauge, the audience that we have today. We have 2 webinars today, just so you know. So if you have a colleague who might be in a time zone that, this doesn't suit, feel free to forward them the second session, which you can find on our website under webinars. But we think we have a very mixed audience. As I said, this topic is really the intersection of telecoms and manufacturing. So we just want to understand who's in the room today. So you can see the options there. Are you a telecoms operator or some kind of network service provider? So you may not be a traditional telecoms operator, but are providing network services to end customers and to enterprises, including manufacturers. Are you a telecoms vendor, so a technology company providing software, hardware, services in the telecoms industry, and might be providing components of a private 5G solution? Are you a systems integrator, stitching all of that together to bring the service and the solution into your customers' premises? Or are you from the manufacturing industry? Are you a manufacturing company? If any of those options don't match where your organization sits, then feel free to click Other. So we will just wait for a few more responses to come in. All right, it looks like about 80% have responded, so we'll share the results now. Great. So it is a bit of a mix. It looks like what's interesting is a fair few from the, from the group who is actually delivering the private 5G network. So hopefully this will help you, this webinar today will help you, I guess, refine your proposition, understand what your end customers' needs are, what the real benefits are. And then those on the more on the manufacturing side, hopefully it'll be the reverse, which is maybe learning a little bit more about what private 5G is, what that private 5G network is all about. Great. So without further ado, I will hand over to Yasmin, who will kick us off with our first presentation. Over to you, Yasmin.
Thanks, Dalia. So today what we want to do is just to cover a little bit of the scene setting, understanding the private 5G opportunity, understanding some of the supply side challenges before Niels will go through some of the demand side challenges from the manufacturing perspective. So just to kick us off, there has been significant interest in 5G and its capabilities in driving digital transformation for different types of organizations, including the manufacturing sector. A recent forecast that we did, which has been based on surveys and interviews with over 100 senior manufacturing industry executives, actually estimated that 5G could unlock up to $740 billion of value in manufacturing in 2030. And this has primarily been driven by enhancements of existing use cases and also some of the new use cases as well that 5G can enable. But then when you bring this to more of the private 5G element, private 5G in particular is touted to bring these enhanced capabilities of 5G in terms of ultra-low latency, reliability, mobility, etc., and tailor them to customer-specific needs. So it can also then do this in a way that provides ubiquitous coverage for the shop floor quickly. You're able to tailor this to specific use cases and so on and so forth. In particular, private 5G is also a key opportunity for production companies to address a lot of that fragmentation and complexity that stems from the number of different interfaces that they have to manage. Our research with different industrial companies found that 60% of them identified at least 3 different forms of connectivity across their site operations, with over a third of the sample using 4 or more. And we suspect that this could be an underestimate, with many enterprises having multiple instances of each, and each of them addressing or linked to a specific use case or application. And although it's not necessarily realistic to have a single network serving every use case, and in reality, we will have moved to a more sort of hybrid networking world with a mix of wired and wireless connectivity, what we find is that private 5G can provide the ability to support multiple use cases and associated requirements, providing production companies the opportunity to reduce operational complexity and fragmentation across the number of protocols to manage. It can also reduce the number of potential attack surfaces as well. And by reducing that complexity and number of interfaces, they can also lower overall total cost of ownership through that consolidation. With regards to some of the challenges, though, within the supply side, we've identified 4 key ones. The first being, the lack of vertical knowledge and expertise from the suppliers in understanding, the manufacturing business, the manufacturing challenges, and how this differs across, for example, the automotive industry, discrete manufacturing, process manufacturing, etc. The second is around the sales approach. Private 5G often requires a different type of approach away from sort of this one-size-fits-all that many tend to be used to. The third one is, given the level of investment as well, it's often important to be able to identify that anchor use case that can justify that investment. And then the last challenge is around being able to quantify what the impact is of having a private 5G network on, the customer's business and operations as well. So just to dive into this a little bit deeper, going into the first one around the lack of vertical knowledge and expertise, many of the suppliers, whether it's the telecoms operators or other network service providers or also other players within the broader ecosystem, often sort of lack the vertical knowledge and understanding of the manufacturing challenges. private 5G should be an enabler for different manufacturers to transform the way they work, which means that often at times it requires engaging stakeholders beyond just the network or IT teams. This includes those actually on the running, the processes on the shop floor, the operational technology / OT teams. This means that the challenge and the key requirement is being able to articulate how private 5G can address, the most pressing pain points for these different types of stakeholders. In more detail as well, this also requires specific knowledge and understanding of, the industry and of the customer's business. The second challenge is around the need for a different sales approach and specific capabilities. With regards to those that bring private 5G solutions to market, this requires the move from a more sort of transactional approach to a more consultative approach. This often, means longer sales cycle, dealing with different types of stakeholders, a different process with regards to working with customers to understand their challenges and understand, what their requirements are. It's not sort of a technology push, but it's understanding, what type of technology best fits the, the needs that the customer has. And as we mentioned as well, because of the different stakeholders that are involved in that decision making, it requires some of the partners in that ecosystem to be able to help drive alignment across different stakeholder groups. The third challenge here we wanted to highlight is around cost. So 1 out of 3 enterprises, based on research that we've done, cite the cost of a private network as some of the most pervasive challenges in comparison to others that they've ranked in deploying a private network. And so in order to justify that, the investment, often at times, customers want to be able to, focus on enabling or addressing a particular pain point or enabling a particular use case. And therefore, this use case must be, using private 5G for this use case must be a strong enough motivator for the overall investment in terms of the impact and key metrics, whether that's around operational efficiency, unplanned downtime, sort of flexibility, the risk to the workforce, etc. And on top of that, the ROI not only needs to be positive, but it also must be more favorable than going with other existing connectivity solutions. It has to be better than, the status quo today. And the interesting thing is the fact that, once the anchor use case has been identified, adding on or using that existing private 5G network to support other use cases over time only increases the overall, ROI further and improves the overall TCO over time. The last one as well that which we'll dive into is, many enterprises, although they are starting to slowly understand what 5G means for their business, they often lack a clear view as to the impact on key metrics. And so one thing that, our esteemed colleagues will talk about later is the fact that 72% of enterprises sort of lack understanding of the overall return on investment of private 5G. Manufacturing companies as well as other customers want to be able to understand the potential impact on key metrics and how this relates to their specific business goals and objectives and, technical requirements. So before we dive into more detail, I'm going to hand that over to my colleague Niels, who will showcase the demand side challenges in that point of view as well.
Yeah, thank you, Yasmin. And thank you for these impressive facts. So this actually underlines that the webinar is coming at exactly the right time. And I'd like to a little bit elaborate on the relevance of 5G return on invest from the manufacturing perspective. So I will do so by, hopefully this works. Yeah, okay. By addressing the challenges we see in manufacturing today, and then furthermore elaborate on the concept which we call network adaptive production, and then leading to how to prove the added value of 5G. And then motivating for the topic of today. So which are the challenges we see in manufacturing right now. So there's a delay. Sorry for that. Okay. So there is always a concept mentioned in the public discussion. It's called resilience, and resilience in production is actually made up of multiple parameters, which we call, for example, efficiency, which is the ability to produce in the best possible economical way. Furthermore, effectivity is the ability to produce with maximum availability, performance, and quality. Then zero defect manufacturing, which came up in the last 10 years, as the ability to react on and compensate on critical events, which you need data for, of course. Then last but not least, scalability and flexibility is actually the ability to adapt production to variance and batch sizes, which is also very important when it comes to individualized production or mass customization. But of course, this creates a lot of challenges, and the field of tension is quality versus time versus costs versus scale, which has to be resolved. And to underline the relevance of these challenges, I brought a quote coming from Professor Georg Schlesinger, who he's a production researcher, who said in 1911 already that the dividends sit on the cutting edge of the steel, but the speed of these cutting edges is a function of the machines that move them. That actually underlines the economic relevance of resilience, and by this quote, he actually created a link between the economic power of a company and the efficiency of the production itself. And this is still valid for, today, of course. Nevertheless, more than 100 years later, of course, we have this Industry 4.0 discussion since a couple of years, and we have new concepts. And one concept I'd like to motivate here is the architecture of a network adaptive production. What is that? That's actually the concept of understanding production of, on the one hand, on the physical layer, which is called the shop floor. On the shop floor, you have the physical machines and employees. And then furthermore, you have a data layer where you aggregate all the data coming from the production. And in order to link the two layers, you need connectivity technologies. And 5G is, of course, very attractive to look at because it provides, or it, let's say, it promises ubiquitous connectivity. And then across the value chain of a production line, then of course you aggregate multiple different data types, and you have different data sources. What are you doing with this data? You need to create a value. To create the value, you need to analyze the data and feed it back into the production. That's actually the concept of the so-called network adaptive production. What are the key aspects of network adaptive production? Is first of all, a digitization of the production through ubiquitous connectivity with 5G, for example. Then utilize data for a flexible and resilient production. Then furthermore, economical and sustainable production through zero defect manufacturing and flexibilization, where of course data is essential to use. So one implementation of this architecture is being implemented in the 5G Industry Campus Europe, which I'm coordinating. And the 5G Industry Campus Europe is actually the largest industrial 5G testbed till date. It's made up of 3 different 5G indoor networks on different shop floors with a total size of 8,000 square meters. And these 8,000 square meters are fully covered with different types of machines and robots. And we are looking on applications of 5G to manufacturing and logistics. So in total, we look at production tasks, and we are looking at realistic or real-world use cases, not using 5G so much in the lab. And furthermore, there's also an outdoor network of 1 square kilometer where we can address handover scenarios between different shop floors, for example. The network is set up both as a 5G non-standalone architecture and as a standalone architecture. So that means we have a 4G and a 5G core network, and it's operated in the spectrum of 3.7 to 3.8 gigahertz. And for 4G, we use the band 40 at 2.3 gigahertz as an anchor band. So the 5G Industry Campus Europe is a so-called model region of the German government. And we have multiple partners, and one of the partners is Ericsson, who is supplying the network equipment. With the 5G Industry Campus Europe, we want to support the companies to start with 5G on an early stage, to collaborate with us and use the infrastructure together, and go into and address the challenges I've motivated already. So, but what are the application areas which we are looking at? We look at mobile robotics. Of course, mobility is a motivation for wireless connectivity. Of course, logistics. We all know the AGV use cases. Then furthermore, we look at how 5G goes into machining, and how to safeguard the delicate manufacturing processes. So we look at process monitoring. For this, we need smart sensor solutions, wireless sensors, which go even into the machines or in the infrastructure. And then in order to utilize the data transmitted via 5G and boost the performance of the overall solution, we look at on-premise edge cloud solutions, how to integrate that, and how to utilize data in so-called data economy platforms, and also looking at how is the interlink between different production sites if they are connected with 5G, and what is the architecture, how to transmit and exchange data. Okay, so sounds good, but we see that 5G is not implemented in the daily production today. So why is that? And what do we need to do? One of the overarching questions for the whole society, and especially also for production, is how to achieve sustainability in production. And with respect to 5G, we need to analyze how 5G contributes to sustainability in the production. So the question is, how can 5G support companies on their way to net zero CO2 emissions? This is something that, first of all, needs to be proven on a technical level. So we need to carry out experiments in order to understand how 5G, for example, can decrease failure rates or can decrease cycle times. If we know that, then we can, as a next step, calculate the technical and economical impacts on the manufacturing side. So to answer the question, what is the economical benefit of 5G use cases? So that means that we can then feed the experimental data into the calculation of return on invest. And for that, we have developed a tool which will be the subject of the next presentation.
Yeah, thank you very much, Niels, and welcome everybody also from my side. I'm Raphael Kiesel, and I'm heading the department at WZL here in Aachen as well. And as already said, we developed a tool which allows to really see what the benefit of 5G is, both from a economic point of view, but also from a technical side. And the reason why we developed this tool, and earlier it was already said something about the motivation. So as Yasmin said earlier, we found out that 72% of companies in production are missing the understanding of an ROI, but also with nearly half of the persons which were asked miss a lack of technical use case understanding. And that's why, which was already said earlier, there is currently a lag between this high potential which is expected by 5G and the implementation rate. We further figured out that 70% of the vendors need a business case in order to really invest in the technology, and that there are the business outcomes, and that there always has to be a solid investment case for 5G. And then we asked the question to ourselves, like, how can these concerns be solved to reveal the real impact of 5G in production, which is of course interesting for production companies on the one hand, but also for systems providers on the other hand. So I'm super happy that both of you are here today. So in order to do so, and that's really important, and as we are also coming from the production point of view, we said we have to start in really understanding the technical capabilities of 5G. Niels just presented what's possible in there, but especially for manufacturing companies, it's sometimes a bit hard to understand what does an increased availability, an increased reliability, or decreased latency really means. And especially what's the technical impact on the use case, because of course there has to be an understanding of what's in it for me from a business point of view, but therefore the real impact on the techniques first of all has to be understood. I mean, we heard it earlier, Niels talked about resilience, we heard zero defects, Yasmin said earlier the increased throughput. So what's the real technical impact on this? And in most cases, the technical impact also has an economic impact on the use case. So this is the triplet we are having as an idea of the tool in order to then figure out what's the price I'm as a manufacturing company are able to pay. This means that in the tool, and you will see this in the demo in a couple of minutes, you are able to enter a price to see, okay, what's, for example, my NPV. But as there is also at some point still a high uncertainty about the price or the network cost, we said that at least the tool should deliver what the maximum price would be that you are, as a manufacturing company, are able to invest, or seeing it from the other side, what's the price you are aiming for? So what's your target price in case you are a 5G provider or a service provider? And in order to do so to have this use case analysis and to then figure out what's the architecture boundaries from this technical, from this investment point of view, we have a 5-step model to evaluate this. It starts with specifying the application, because here we figured out by also talking to industry that it's important to understand application itself. Niels just had this nice picture with the 6 use cases. So it's important to get down to this level. So not just saying, okay, your factory is, let's say, 100 or 1,000 square meters big, so that's your ROI. No, we really have to go and understand the application, understand the use case and the benefit behind it. And therefore, we have to first specify it. Then we have to select goals, both from a technical point of view as well as from an economic point of view. Why is that? Every company has a different goals they are pursuing. I mean, Niels just also presented the topic of sustainability, which is a big topic for some companies. But depending on the use case, it can be an increase of quality, increase of utilization, and this should be considered in the model. And by choosing the goals, we also guarantee that you only enter the data which you really need, and not data which is might not necessarily for your decision making. In the third step, we call it select control task. This means, as 5G is often having an impact on the control loops, that you can design your use case. You will see this in a demo for an AGV use case, what we mean with it. Then after you specified the selected goals and control task, you have to enter the data and then get your evaluation results. So now I will show you a bit about the theory behind the tool, and then you will get a demo of the web-based tool, which can be used by every browser, so you don't even have to install anything just at least a browser, but I think as you are here that you probably have a browser. So first we specify the application. Here I don't want to go through every of these bullets. It's just to show what's behind the model. So we have on 8 levels these applications are specified, starting of course with the application itself, with the use case, and then choosing depending on where you want to compare it to, whether it's a 4G, maybe Wi-Fi 6, or if you are just replacing wires, if it's a greenfield brownfield approach. So all these things which are important when deciding on whether 5G might be an option or not. Then talking about goals, on this technical point, we defined 7 goals, which are flexibility, mobility, productivity, quality, safety, sustainability, and utilization. So these are goals which are, of course, affected by, or where we expect an effect of 5G. But these are also goals which are in general important for production companies. So what we didn't want was, let's say, invent new goals which companies might don't have. So for example, if we talk about transparency is always important, but transparency is always just an enabler to, for example, increase the productivity or increase the quality. So here we really try to be on a level that production companies understand in order to choose the goals properly. And once these goals are chosen, in the background we defined certain KPIs, which are all operationalized with a certain formula and with certain elements. So once we know what the 5G effect is, that based on this data, based on the elements, and based on the KPI, we really in the end can quantify our goals. From an economic point of view, here we defined 4 goals, or 4, let's say, measures which can be chosen in between. So that's the net present value, measuring a beneficial of the investment, the return on invest, which stands for an efficiency. So how much do I get per euro that I invest? Then the OPEX per product. That's because it's expected that, especially on this operational point of view, there's a cost saving, and that a lot of production companies are aiming in decreasing the operational costs per product. And last not least, the payback time, as this is of course important when you might don't have that you want to see how fast is my investment reinvested, so that you see how much time does it take that 5G really brings the value to my company. Then the third step is selecting the control task. As I said, we will show you this in the demo. And here it's important that in order to figure out where the real benefit is, we had to be on this technical level, so understanding how a wireless control, an increased availability, a decreased latency, or an increased reliability have an impact on the use case. They're currently in the tool 2 applications, and the use cases are implemented, but within the next months, more applications and use cases will follow based on this general criteria of control task choice and the impact of 5G on these control tasks. So once you characterize the application, shows the goals and the control tasks, the tool automatically tells you which necessary data you have to enter. The data is split into 4 groups, as we figured out that not in all company everyone is available to or capable of entering all the data. So of course it's possible to then, during the evaluation process, to just save it and send it to somebody else, so that the other person might enter the data you are not able to enter. And once this is done, the tool shows you both economical and the technical goal evaluation. And here, what we, to also better understand what the impact of 5G is, we try to show what's the overall impact, and this is shown based on a delta. So what's the percentage change between the 5G case and the case you are comparing it to? But we also tried to show what's the impact of increased reliability, of increased availability, and lower latency, to really see where the impact is coming from, and not to say, okay, this is 5G, now magic happens, but to really show and to really connect this technical point of view with the evaluation point of view. And after I showed you the theory, I would just say, let's try the tool and let's have a look into it.
Great. Give me a second. We should be able to see a video shortly.
So now we're here in the online tool. You can see it's web-based, so we use Google Chrome. Nevertheless, you can use every browser you want. So you can see here on the welcome screen, you could get the information about the tool which you just got in the presentation, or you start your evaluation. And then you see this overview, this 5-step overview to evaluate your application. We start with the specification of the application. Let's say we are now interested in an AGV application. And in this case, there is currently one use case defined. In case more use cases are coming up, this could easily be added. So for this use case, these are the performance requirements which are assumed. And you can see here we have minimum and maximum application performance requirements. For the maximum ones, we assume that only 5G is an option. For the minimum ones, we see that also others are options. And I mean, we know that there are currently 4G based AGVs running. So let's see whether 5G really has an impact. So we compare it to LTE. Here, these are the specifications of the compared technologies. As this is not all defined as for 5G, we here leave the option to maybe change availabilities and reliabilities as it is assumed by the user. Then, and this should not be forgotten, that 5G is not a holy grail or a magic box, so that just companies coming to you, giving you a 5G bag and everything is in there, but you also need to have some control system parts, components, and some network architecture components. And in order that this is not forgotten, we here have this quick overview, which will be interested later on if you enter the investment data. Let's assume only the 5G things are necessary and the rest is already available. Then we can choose whether we have a brown or a green field. Let's say we have a brownfield application. We can enter here this data and we use the identical application for the 5G use case. Sometimes, even if it's the identical application, the speed might be higher or on offloadings might be decreased as the latency of 5G is lower. So we have a faster reaction time and we can go faster due to this latency. But for now, we assume that it stays the same to show you later on how this how this not improvement or not increase is considered in the evaluation. And then application specified. So green is always a good sign. So you made everything, or we made everything, filled out everything correctly. And we go to the next step. So here we can select the goals. I know probably not every goal is important for this use case and for this application. However, due to demonstration reasons, let's have a look at all of them. And as we are also super interested in economics, we of course want to get as much information as possible. So green is again good, and here it also gets green if you only choose one goal. It's just important that you choose at least one goal, because otherwise it doesn't make sense to evaluate the application. Then we define the goals. So here we have the straight, for example, 1,000 meters. We have, let's say, curve of 20 meters.
crossing of 20 meters. Then we have the curve here. And of course, an on and off loading. So let's continue. And then we have to enter the data. Again, as especially in bigger companies, maybe not one person knows all of the information. This can be saved and another person can enter the data. And if you, for example, say what is meant with the area of the total plant, you can just go here and get the information. So this is done for all data which needs to be entered. We click through it, so we filled this out beforehand. So just to save some data. So here, for example, the batch size we could add to 5. We continue. And the production data. And the investment data was already added. Here again, as I showed in the presentation, the goal in general is to figure out what would be the possible price to enter. So you don't have to enter any investment data if you don't have any information about it. Nevertheless, we just did this here. Then we can get the evaluation results. As we chose all goals, all the goals are here considered. All goals are defined as max, so you can see that most of them are improving. We can see here then on a stacked level why they are improving or why they are decreasing. So whether it's due to availability, higher reliability, or just ICT effects. And when we, for example, go on one goal, we can see here the different KPIs being defined and how they change and how the total stack then changes. If we continue, we see the evaluation of the economic results. Here in this case, the net present value. And in the end, if we go to show goals, all the goals are summed up here. So both technically as well as economically. So then the evaluation is done. Now you could just delete the data or add another use case. If you delete it, everything gets blue and the party starts again.
Great.
Yeah. So this was our presentation, yeah, I just want to add that this was also part of a research project called 5G Smart. So yeah, evaluated with some other industrial companies. So there was definitely a proof that this works. And with this, Dalia, I hand back to you.
Thanks, Raphael. Thanks for that demo as well. Really helpful. So can I ask Niels and Yasmin to come back and join us for the Q&A session? So just a reminder to our attendees, hopefully those 3 presentations plus the demo spark some questions. Please do drop your questions in the questions box that you can see it in the picture there, and we can get going. So let's kick things off. I think one thing I'd like to gauge from all 3 of the panelists is where we are in the adoption cycle when it comes to private 5G in the manufacturing industry. Maybe Yasmin, if you can give your perspective, and then Niels and Raphael, feel free to jump in as well.
Yeah, sure. I think it is still a little bit early days. I think, in certain markets, they're a little bit more ahead in terms of, the 5G spectrum licensing regime. So it is available to particular, industrial use cases, and specifically available to, manufacturers themselves. In other markets, less so. That's still in the process, but there is interest, for example, in starting with private LTE. we have seen, you know, an increase in the number of trials and pilots and proof of concepts, but
You just cut off for me, Yasmin. I'm not sure about everyone else, but could you just repeat the last bit? Sorry. Okay, maybe let's move on. So I think it sounded like Yasmin was saying, you know, it's kind of in proof of concept stage. Niels, is that something you'd agree with? Obviously, you are involved directly in those proof of concepts and trials, but do you see it, you know, maturing quicker, faster? Where do you see the adoption cycle?
Yes. So I'd like to also mention what Yasmin just motivated, that the spectrum options is one of the leveraging factors in my opinion. When looking at the German situation, so Germany started really early with private spectrum. Until date, I think more than 170 licenses for private spectrum have been granted, and approximately half of that went to companies. When looking at these companies, and I'm in discussion with many of these companies who started with 5G already, it becomes clear that 5G is not being used in their daily production yet. So all of these companies are doing a lot of trials and validating 5G from a technical perspective. So that's a little bit understandable, because there's no, let's say, 5G enabled production equipment that you can buy off the shelf yet. The only thing that you can buy is, of course, 5G routers or 5G modems, which is working fairly well already. But there's still a gap to be closed, and with the help of these many testbeds that we have in Germany and also worldwide, actually, we try to close this gap jointly.
And maybe adding on what Niels just said, I think there also, and that's also why we have this in a tool, there is a big difference whether you have, let's say, a factory which was maybe just built up 5 years ago with the best Ethernet connections and everything, or if you're just thinking of retrofitting or building a new factory. I think this is also a fact which we should not forget. And I think that the business case, not I think, but I'm convinced that the business case, when you say I'm really building up a new factory manufacturing site, that you can't get, that you have to consider this topic, because regarding also flexibility from a factory layout perspective, there are complete new ways of designing your factory. But of course, when you just did this, you probably, if you did a really bad planning, don't need to rearrange everything now.
I would add as well, I think, you know, we have to think about that broader ecosystem. You know, in most cases, these are brownfield deployments. They rely on, you know, let's say different machines and equipment being connected. And often in case, let's say if we take, you know, the AGV example, if certain solution providers have designed around connectivity issues, let's say with challenges around, you know, reliability of Wi-Fi, or, you know, with mobility issues, then I think that often can impact, you know, the adoption cycle or that take up of private 5G. But, you know, we've seen this slowly changing, and there is sort of that increasing, you know, awareness of that broader ecosystem in terms of those capabilities. But it's still underway.
And
yeah, no worries.
So, sorry, Daria, go ahead.
No, I was actually going to come back to your point, Raphael, about the greenfield sites, and it almost suggested that it's a no-brainer for manufacturers to implement 5G as they're designing and planning new sites. I mean, is it fair to say, you know, more than 80% of new manufacturing sites will use 5G, or is that an exaggeration of what's actually happening?
Yeah, so this is 80%. That's a pretty high number, and I think we always have to see, is it then all, so are we replacing all wires, for example, or is it just we say we have certain machines? But I think definitely that at least 100% of the companies should consider it, and that many companies will do it. And I think one thing, and this is also a discussion I just had last week, I mean, what we are doing now, also in the tool, we are starting at a, let's say, from the potentials at a quite I don't want to say low level, but we're looking at the use cases as they are right now, because we said we want to be as concrete as possible. But once 5G is implemented, there's a lot about what possible new use cases are there. And that's not even considered yet in this tool, because we said you first have to really understand the impact on the existing use cases. And we didn't want to build up, let's say, golden castles, which we can then fulfill. But once this data is there, talking about predictive quality or new business models, that's also something we have to consider. Then, of course, the whole point of data, of transparency, and so on comes into place. But as Niels said, therefore, we first need the equipment, we need the use cases, we need somehow to prove it to do this next step. But there is so much on the line. I think Niels can even say it more from a technical perspective, and you also, Dalia, regarding Edge, for example. Yeah, there first of all we have to implement it and then see what's still to come.
So yeah, that's totally true, and I'd like also to add that I'm very convinced that 5G will keep the promises that we know of, and we see it especially from the experience of the 2 years of the 5G Industry Campus Europe. We see that all the premises will be kept, and I'm pretty convinced that all the use cases we are thinking about will be realized with 5G one day. And then the only deciding factor remains: what is the return on invest? So this will be the motivation number one for the companies to start with 5G. If they see they can save money with it, this will be then a no-brainer to start with 5G.
Yeah, and just on that, I mean, one of the ways, we always think about helping to make the business cases if there's a strong use case, a compelling use case. One of our audience asked, what is the anchor use case, in that campus environment? What are you seeing at the moment, Niels?
You mean on the 5G Industry Campus Europe? There are multiple ones. One is in assembly, where colleagues are using mobile robots for lineless assembly, which is a very new concept being adopted by the large automotive companies right now. That means that robots combine to, let's say, production islands, making it really flexible. And for that, of course, 5G is key, because you need connectivity for the mobile robots. And there's a lot of sensors. Of course, you need to provide safety for the workers. That's one of the anchor use cases, very prominent. The next thing, of course, is the AGV that we are looking at as well. In our case, we not only look at it in the indoor usage, but also going outdoor, because, of course, a lot of transport is happening on the whole enterprise area. We have multiple shop floors in a closed area. So then, of course, handover scenarios come into play, and how's the navigation scenario looking indoor and outdoor, how's the mapping and so on. That's what you're looking at as well. And then at the Fraunhofer IPT, we are looking very much on machining, so conventional milling, drilling, turning tasks, and so on, where process monitoring is essential, especially for safety critical or delicate to manufacture processes, products, and where we use wireless sensors, which are really flexible and offer, with the help of the low latency, very low reaction times when, for example, critical incidents happens, like the tool breaks or the cutting edge breaks, where you need to interrupt the process and even control the process. So that's not one anchor use case, it's multiple ones. And that's pretty much in the interest of the company. So we work with many companies already. So more than 50 companies are involved into our projects. That actually shows the large interest actually in 5G. And yeah, companies can start early here. They do not have to invest into 5G infrastructure directly. And yeah, that's the concept of the 5G Industry Campus Europe.
Yeah, I think broadly speaking as well, just to add to that is, Niels mentioned a lot of different use cases that might potentially have an impact on employee safety, or, things that could potentially have a risk to, the production process, or the, the health and safety of those on the shop floor. I think these in particular, obviously more of the mission critical ones, I think that's where private 5G in particular can play, quite an important role in providing that, reliability, that low latency to be able to react to certain incidents or potential incidents before they happen.
That's cool. We have a few more technical questions have come in on things like standards and things. One, which is one for you, Raphael, specifically on the tool, I would say, is the tool able to differentiate the gains or the benefits between 5G non-standalone and 5G standalone, or have you looked at that in the tool?
Yeah, so that's possible from a technical point of view. So I mean, here I'm also, or Niels and myself are also currently working on together with colleagues from Niels on to evaluate this, because what's in the end the difference between non-standalone and standalone we're looking at. That's also again from a technical point of view. So how does non-standalone and standalone affect latency, affect reliability, affect availability of the system? And this can be changed in the tool, so by choosing non-standalone, standalone. So yes, it can be, and again on this technical level, because that's always important for us.
Yeah, one example is that we see that, and we have measured that, looking at the 5G devices, the power consumption is less for when it's operated in 5G SA. And this can, of course, be used or entered in the tool, though that's not the, let's say, the leveraging factor, but it's one of the details that can be used here.
And maybe one thing, of course, that's how much you pay as an OPEX for as an operational expenditure for the network itself. Because if you have the private, so private versus non-private, same way, then we are now talking about private a lot, but it's also, of course, something we should consider.
One question just came, which is quite interesting, because the first, I guess, use case we have in the tool is the AGV one. So the question is, has your tool been evaluated by AMRs, or autonomous mobile robots, or AGV, automated guided vehicle companies, as being valid? As I'm aware, today most of the AMR/AGV companies have mechanisms in their car body to make sure the vehicles are not dependent on the wireless network. So it'd just be interesting to hear, any feedback, anything that you're learning by maybe engaging with some of those manufacturers of AGVs.
Yeah, of course, some features are integrated in the AGV itself, but this always depends on how the AGV is coordinated. And we are especially looking for the centralized coordination, so it means computing is in the cloud. This has several advantages, and Niels, I see you nodding. You can also add this then afterwards, but there are several advantages by, for example, just decreasing the size of the AGV and being more flexible by a central organization, as for example Niels said, the lineless mobile assembly. There we are talking, and also about edge robotics, for example. But yeah, so there we see, and that's what I think, Niels, you also meant with 5G, with 5G ready applications, because these 5G AGVs, they are currently being developed, and then there's the big effect.
Yes, exactly. So having the AGVs operated in a central management and with a global map enables the fleet control to operate AGVs probably faster, because let's say all of the sensors of the different AGVs contribute to see what is happening in the factory, and that yeah, gives you the opportunity to increase the speed, and the speed is of course the economical factor here.
Great. So I'm afraid we're going to have to wrap up the Q&A. I did actually have a couple of other questions to ask you guys. If there are any other final questions, feel free to drop them in and we can answer them offline, because we'll share a Q&A document answering those questions. Other than that, I just wanted to say a huge thanks to our partners, Niels and Raphael, for joining us today. And I know this is one of 2 sessions, so we'll speak later anyway. And Yasmin, thanks a lot for your time in the presentation too. Just to wrap up, we are starting to engage customers who are interested in the tool. It's available. So if you'd like to either meet with us at Mobile World Congress in Barcelona, there's a link there that you can note down and use. The slides will be shared, so that might be easier to access that link. And then we can also set up a call in the next few weeks too. So do reach out if you're interested, and we hope to speak to you soon. Thanks a lot, everyone.
Thanks, everyone.
Bye.
Bye-bye.